Hi Geometry, this is Unit 5, Lesson 9 on page 577 of our workbook. At any time during this volume lesson, feel free to pause the video and try the problem on your own, and then come back and double check your answer with the video. So let's begin with these two-dimensional figures. So the blue figures on graph paper are considered two-dimensional figures. So we're going to rotate them around this darker, thick line, vertical line, and when we rotate it, we're going to create a three-dimensional figure out of it. We're trying to figure out what it's creating. So in this first one, if you can imagine, as it wraps around, this is creating a circular. If you could imagine a pencil and you're flipping a piece of paper around and around and around, it creates a circular motion. And so I'm creating a smaller cylinder on top as it flips around and flips around and flips around. And I'm creating another cylinder on the bottom. This cylinder made because the bottom rectangle is wider than the one on top. So it's almost like a cake. It's a stack of two layers, the top layer being a little bit smaller. So let's sketch this. Let's sketch it in this part. So I've got this cylinder on top that has a radius of 2 units, and counting squares, it is 1, 2, 3 squares tall, and then I have my base. And then I have the bigger cylinder on the bottom. So I'm trying to make a cylinder that looks like so this first guy is sitting in the middle of the bigger one that's on the bottom. And this looks like, if I could count from, let me get a different color so you can see where I'm looking. I'm looking at this distance here, which looks like it's 5 squares. So my big one has a radius of 5 because my little one has 2 and the larger one is 3 squares outside of that. And it looks like the big one's height is 3. So I know that this is also 3. So I really have 2 cylinders here stacked on top of each other. So for part 2, it wants me to find the solid's volume. So to me, it makes sense that if I found the cylinder on top, so the cylinder on top, if I found its volume, and then I found the volume of this cylinder on the bottom, I would simply add them together because it's just 2 solid cylinders sitting on top of each other. So let's figure that out. The volume of any shape, the volume is the area of the base times how tall it is. In this particular problem, my base is a circle. So my area of a circle is pi r squared. So we think about the volume of a cylinder as being pi r squared, that's the area of my circle, times the height, because that's the volume of anything. You find the area of the base and you have circles stacked from the bottom to the top of the height. So it's a stack of circles, and to find the volume of all of them, I would take one of the circles' area times how tall it is, and I would find the volume of my cylinder. So in this problem, it's pi times 2 for the little one squared times the height of 3. Be careful when you do your math. PEMDAS tells me to do exponents before multiplication. You've got to do 2 squared or get 4 first. This is really pi times 4 times 3. You can write that as 12 pi, and what is this? 1 square centimeter. So this would be centimeters cubed, or you can multiply by pi on your calculator. I'm not sure what decimal that is. I don't have my calculator handy, but you can do 12 times pi and then get a decimal value. I would not. I would keep it with pi for right now. So then the cylinder on the bottom, same formula. The volume is the area of the base times the height. In this case, that's pi times 5 squared times 3. So that is 25, because I have to do 5 squared first. 25 times 3, or 75 pi centimeters cubed. So the total volume is the volume of both cylinders added together. So in this case, it's 12 pi plus 75 pi, which comes out to be 87 pi centimeters cubed. If you did that in decimals, you would have 87 times pi on your calculator. Don't use 3.14, use the actual pi button, and you would have approximately 273.32 centimeters cubed. Those answers are the same. One is in terms of pi and one is not. So let's continue with B. B is a different problem. When I take this blue rectangle that you see here and I rotate it around this black vertical line that I see here, I actually have an empty space. If you can imagine, this guy is this blue rectangle. Whoops, I need to make it come up a little bit. This blue rectangle, there's this empty space where it's not touching my black line as it goes around. So it's creating this almost donut-like shape, if you will, with this missing part in the center as it goes around. So this shape has a hollow center, which is like a cylinder here, has this hollow center, and it is this solid outside part. So this inner part that's hollow, I can't really see. Let me make it look more like a dotted line, and I can't really see this. And so that's my hollow part inside, and then I've got my outside part. So my inside part, if I count, it looks like this is 3 squares. So it looks like the radius would be 3, or total distance is 6 all the way across. This is 2, this rectangle, so I know that this is 2 right here. The height, 1, 2, 3, 4, 5, 6. Looks like we have a height of 6, both inside and outside. So for this one, if I want to calculate its volume, I'm thinking about this. The volume of this one, it seems to me like if I could find the volume of the whole thing, and I would subtract out then the missing inside space. So I need to find the total, or the whole cylinder, and I need to subtract out that empty space inside. So let's try that. So my total volume, I'm going to label this total volume, so I remember what's what. That has pi r squared h, where in this case my r is 5. If you can imagine this whole thing, I would add the 3 and 2. So this would be pi times 5 squared times my height of 6. So that's 25 times 6 times, and I get 150 pi. So now my empty space inside. So now I need to calculate my empty space that's inside. That's also a cylinder in shape, so I know the volume is pi r squared h. I know the radius on the inside is 3. My height is still 6. So this would give me 9 times 6, or 54 pi. So to find my volume of my piece, I would do my 150 pi minus my 54 pi. Looks like I would get 96 pi. And in this case, this is centimeters. It says up here that it was 1 square centimeter. Centimeters cubed, that's what volume is. Centimeters cubed, centimeters cubed. And if you want to multiply 96 by pi, then you would get 301.59 centimeters cubed. And that's an okay answer too. I would leave mine in terms of pi, but both answers are correct. Take a look at the next page, the first page of the practice actually. So I want to discuss both number 1 and number 2 with you. So first of all, let's jump down to number 2, 2a. So this is another example of when I rotate my blue rectangle, there's going to be a little bit of empty space. If you can imagine, when I rotate this, I'm going to have a 1 unit radius circle, or 2 units in diameter. I'm going to have this empty space inside. And my rectangle then is on the outside. So if you can imagine this swinging around, there's that empty space on the interior. So when I'm looking at my possibilities, this is 1, 2, 3, 4, 5, 6 in length, 6 in length. This is a total of 2 right here. This is my 2. And this little missing part is 1 square in radius, 1 square in radius. So A would look like the diagram in number 3. So going back up to number 1, when you rotate around this particular one has no empty space. It's touching my black line. So when I rotate this around, I just would have my rectangle be 3 units on the other side of my black line as well. So my radius is 3. It'd be 6 units all the way across my cylinder, but my radius is 3. So this would be my drawing for A. And then what's the volume? Well, remember, volume is big B times the height. In the case of a cylinder, my base is a circle, pi r squared times that height. So for this problem, I would have pi times 3 squared times my height. Let's go see what the height was. 1, 2, 3, 4, 5, 6. Looks like it was 6 squares tall. So I would get 9 times 6, or 54 pi units squared. And you're welcome to have multiplied the pi times the 54. Let's continue in our practice and look at, it wants us to find the volume, number 3. So we really haven't learned about that many volume formulas. We've been doing cylinders, so I feel like you're okay on A and B. But let's talk about C for just a moment. First of all, you guys, we don't have any formulas for a hexagonal prism. But let's remember what we said volume was. Volume is the area of my base times my height. So if you read this problem carefully, they tell you the area of the base. That's my big B. And they tell you the height. You're able to substitute into the formula to find the volume. Now, D is different. It says it's a prism, and it tells you how tall it is. So my H is 5. It says the base is a triangle, a right triangle, with legs 6 and 7. In other words, if I wanted to sketch this, I could sketch a right triangle with legs that are 6 and 7. Notice they didn't say the hypotenuse was 6 or 7. They said the legs. So remember, when I do the area of a triangle, my base and height have to be perpendicular. These legs are perpendicular. So that would be the base and the height of my triangle. I have a matching triangle on top if it's a prism. And then I have the 3 sides connected. This is my triangular prism. It's a stack of congruent triangles from the bottom base up to the top base. So if I was going to figure out the volume of this figure, remember volume is big B times H. Big B is the area of my base. My base is a triangle. So let's fill in for that. So my volume equals, now I have to think of what the area of a triangle is. Well, we've done that recently. That was 1/2 base times height, the height of the triangle. And so this is really, there's not 2 H's here. Remember, this H is the height of my prism. This H is in my base formula. So let's go find my values for this. So my volume equals the area of my base. So 1/2 6 times 7. That's my 1/2 base times height for my triangle, times then the height of my entire prism. My entire prism is 5 feet tall. It told me that in the problem. So now I just have a lot of multiplying to do. When I multiply this, the 6 times 7 is 42. Half of 42 is 21. 21 times 5 gives me 105 feet cubed. So the volume of this triangular prism would be 105 feet cubed. I have to find the area of my base, and I have to multiply it by my height of 5. Thank you.